So in this video we will solve another pulley problem. So the system is same, but here the difference is that the two masses values are given to us, m1 and m2. And for your information, this is a textbook problem which is taken from H.C. Verma, and this is example number 22 of chapter number 5. Okay, so let's do this problem. So we have again these two masses m1 and m2, and one thing here it is given is that mass m1 is 300 gram, so I will write 0.3 kg, and mass m2 is 600 gram, so it is 0.6 kg. What we have to find out is that first one, the distance traveled by the first block in first 2 seconds. Okay, so this block m1 will travel certain distance is first 2 seconds, right? So that distance we have to find out. So you can identify the problem that we have to find out first the acceleration of the mass m1. So the acceleration of the mass m1 and m2 both will be the same because of this constraint that they are moving with the, if this particular length of the string is changed by suppose x amount, so this will also change by x amount. Okay, because the string is inextensible string. Okay, so let's do this problem. Let's take this mass m1. Okay, so this is mass m1 over here. The upward force is the tension T, and downward force is m1g. Okay, so this is what? This is the free body diagram. In free body diagram we include all the forces acting on the object, and similarly for mass m2g. Now here in case of mass m1, see the mass m1 value is very less, is lesser than mass m2, right? So that means mass m1 will go upward. So in case of mass m1, T will be greater than m1g. Okay, and in case of mass m2, T will be lesser than m2g. Okay, since T is greater than m1g, according to the Newton's second law of motion, the total net force acting on the mass m1 will be T minus m1g, T minus m1g, which is equal to m1a. Correct? So this is what Newton's second law says. And in the case of m2, it will be m2g minus T is equal to m2a. This is the total force, net force acting on the mass m2. This one, the left hand side. Okay, so this Newton, according to Newton's second law, we have to equate this net force, this force to m2a, that is the net acceleration can be found out from this. So now this, after adding these two equations, what we will get, I will directly tell you the answer. We will get m2 minus m1 upon m1 plus m2 times g. Okay, so this is the acceleration we get, and the tension, if you solve, you will get 2m1 m2 divided by m1 plus m2. Just put this a value in one of the two equations, you will get the tension value. So here acceleration of the first block will be, so it is m2 minus m1, so 0.6 minus 0.3 divided by 0.6 plus 0.3, and you have to multiply this by 9.8. so this answer will be in meter per second square. So the acceleration after doing this, we will get 0.3 divided by 0.9 into 9.8. so 0.3 and 0.6 are the masses, right? Yes, so 0.6 minus 0.3, so this is 1 by 3 into 9.8. so what is the acceleration? So it is 3.3 meter per second square. This is the acceleration. So in 2 seconds how much it will travel? So we have to use this formula, s is equal to half at square. So what does that mean? S is equal to half at square means this s is displacement, a is acceleration, t time taken. So this is half, this is from the equations of motion. So this is half 3.3 into 4, so this will be 2, this will be 6.6 meter. So in first 2 seconds the block of mass m1 will move 6.6 meter. So let us, okay, so it is 6.6 meter. Now the second one question is that find the tension in the string. Okay, so how to find the tension in the string? Again, we have the formula, that is this one. So if you substitute this, T is equal to 2 into 0.6 into 0.3 into 9.8. So this is value of M1, this is value of M2, this is value of G, divided by M1 plus M2. So this we will get 2 into 0.6 into 0.3 divided by 0.9 into 9.8. So now this is what? This is 18.18. Okay, 2 into 0.18 divided by 0.9. So this will be cancelled and it will become 0.2. So this will be 0.2 into 9.8 into 2. So 0.2 into 2 into 9.8, we get 3.9 Newton. So the tension is 3.9 Newton.